Okay, let's unpack this. In the fast-paced world of data, it really feels like we're constantly just trying to keep up, doesn't it? For years, the big names in data warehousing like Snowflake and Google's BigQuery, they've pretty much set the standard, promising, well, incredible scalability and that serverless convenience.
Yeah, and what's fascinating here really is that while those solutions definitely delivered on some fronts for a lot of organizations, that initial sort of honeymoon period, it's ending. We're seeing them grapple more and more with, escalating costs, pretty significant vendor lock-in, and actually performance bottlenecks, especially when you get into real-time analytics. And those traditional pricing models can make the total cost of ownership just incredibly difficult to predict. Lots of surprises there.
Right. So what does this all mean for you listening in? Well, we're seeing a real tectonic shift in the data landscape. There's this powerful new architectural pattern emerging, one that's directly challenging that established supremacy. The combination of Delta Lake and ClickHouse, our mission today. To dive deep into this modern data stack, explore its really strong integrations with Microsoft Azure, and uncover some surprising facts about how it stacks up, how it often outperforms the traditional players, actually. Get ready for some serious insights. Could change how you think about your data strategy. Okay, let's start with one half of this powerful duo, Delta Lake. What exactly is it, and why is it suddenly so crucial in modern data architectures?
Well, if we connect it to the bigger picture, Delta Lake is essentially an open source storage layer. Yeah. It brings the reliability of like traditional transactional databases. Think ASIC compliance, atomicity, consistency, isolation, durability directly to your data lake. Now, traditional data lakes, they're great for storing huge amounts of data, structured, unstructured, any scale. But historically, they've often struggled with data quality, consistency, and those transactional guarantees you just expect from a database. Delta Lake really addresses these limitations head-on. It enables robust schema enforcement, data versioning, transactional updates, makes it much more reliable.
So it sounds like Delta Lake is basically adding database level rigor to the flexibility of a data lake, transforming them into these lake houses we hear about. Does that mean it adds complexity or overhead that, data lakes try to avoid?
That's a really good question. And the clever part about Delta Lake is how it adds that rigor without unnecessary complexity. It actually operates right on top of standard cloud object stores, like Azure Data Lake Storage, typically storing data in highly optimized columnar parquet files. The real magic, though, is in the Delta log. Think of it as a digital ledger, like an immutable, super detailed transaction history for all your data. This log records every single change made to your tables. It becomes the definitive source of truth. And this full history is what powers features like, well, seamless schema evolution, robust data versioning, and the really fascinating one, time travel, which lets you literally query your data as it existed at any specific point in the past, which, you can imagine, is invaluable for auditing, rollbacks, reproducing analyses.
Wow, that time travel feature, that sounds genuinely game-changing. Offering a level of data integrity and auditability that's been, well, notoriously difficult with traditional data lakes. What kind of practical things does that unlock for businesses?
Oh, it's a massive leap.
Yeah.
For instance, a client, a large financial institution, they used to spend days debugging data issues. After implementing Delta Lake, they basically said it was like having a Ctrl plus Z for their entire data warehouse. That kind of confidence. It allows these vast data sets to be managed, queried, evolved really, with ease and confidence. Plus, Delta Lake supports standard database operations, insert, update, delete, merge, just like you'd expect. And is backed by a really active open source community, compatible across tons of platforms, Databricks, Snowflake, Azure Synapse, Power BI. Databricks itself, actually, the original developer, they use Delta Lake as their default storage format for everything.
Okay, fascinating. Now for the other half of our equation, ClickHouse. I keep hearing it described as just incredibly, unbelievably fast for analytics. How does it achieve that? What makes it so uniquely performant?
Right, ClickHouse. It's a C++-based, column-oriented, and it was specifically built from the ground up for real-time analytics. Its whole architecture is fundamentally optimized for just blazing speed when querying and aggregating massive data volumes. It does this through several key innovations. For example, it uses materialized views. You can kind of think of those as constantly updated pre-computed answers for your common analytical questions. So as new data streams in, these answers get updated in the background. When you ask a complex query, boom, the work's mostly done. Near instant results. It also uses specialized engines for specific tasks and crucially employs vectorized query execution. This is a bit technical, but it leverages CPU instructions, CMD, to process basically a whole column of numbers at once, not one by one. Huge performance boost from that parallel processing.
So definitely not a general purpose database. It's laser focused on speed for analytical workloads. And when you say blazing speed, we're not just talking marginal improvements, are we? The benchmarks I've seen look, well, jaw dropping.
That's exactly where it gets really interesting for anyone evaluating their tech stack.
Yeah.
In benchmarks, ClickHouse has shown up to like 95% faster querying speeds compared to BigQuery and over 2 times faster than Snowflake. And that's not just a number on a chart, right? It means your business can react almost instantly, turn data into immediate action, not just delayed reports. It also consistently gets about 38% better data compression than Snowflake. So you're storing more data in less space, too.
Okay, but that kind of performance usually comes with a massive price tag, right? Is this the catch? What about the cost?
Surprisingly, no. In fact, ClickHouse is significantly more cost-effective. It's kind of counterintuitive. Studies show it can be up to 100 times, yes, 100x more cost-effective than BigQuery, and typically 3 to 5 times more cost-effective than Snowflake in real production environments. We've seen real-world examples. Prefect cut their costs by 33%, Just Bay by a staggering 10x after moving analytics from BigQuery to ClickHouse. These aren't just minor budget tweaks. It's a fundamental shift in resource allocation. Frees up capital for innovation, maybe more data scientists. ClickHouse is just designed from the ground up for best-in-class resource utilization. It handles huge volumes very efficiently.
Okay, so Delta Lake provides that solid, reliable, ACD-compliant foundation. ClickHouse brings the lightning-fast analytics. What happens when you combine them? Is this combo really the winning combination in these modern data stack wars? Or are there still places where the old guard holds an edge?
Well, looking at the broader picture, the Delta Lake plus ClickHouse combination, it is definitely proving to be a formidable challenger, a serious one. The synergy is really powerful. Delta Lake ensures the data quality, the consistency, the time travel safety net, and then ClickHouse acts as this high-performance query engine right on top of that reliable storage.
It just excels at analytical queries because of its columnar nature and that vectorized execution. It's sort of like having, I don't know, the most robust fuel system paired with a custom-built hyper-efficient racing engine.
Right, the best of both worlds, potentially. So the proof is in the pudding, as they say. What do the actual head-to-head benchmarks show? This combo versus Snowflake versus BigQuery. Yeah, the crucial point is concrete results. There was a comprehensive benchmark using a 1 TB TPCH dataset. Pretty standard test. It focused on different query complexities, real-time ingestion, how it handled many users at once, and it revealed really significant advantages for the combo. For complex analytical queries, ClickHouse averaged a blazing 2.3 seconds. Compare that to Snowflake's 8.7 seconds and BigQuery's 12.4 seconds. Big difference. And for real-time stuff needing sub-second responses, think live dashboards, instant fraud detection ClickHouse hit 95% of queries under 1 second. Snowflake only managed 23% under a second, BigQuery just 18%. That's a night and day difference for real-time operations.
Wow, 95% versus 18%. That is a massive difference, especially for anything needing genuine real-time feedback. What about scaling, handling more users, and the overall cost benefits when you put these two together?
Good question. For concurrent users, handling 100 simultaneous users, ClickHouse showed almost linear scaling. Performance barely dropped, showed a really robust architecture for growth. In contrast, Snowflake saw a 3x performance degradation. BigQuery, a 4x degradation, so ClickHouse holds up much better under load. And then cost. Estimated monthly cost for that 1 TB dataset running 10 million queries. The ClickHouse plus Delta Lake combo came in around $2,300 total. Compare that to Snowflake's estimate of $8,900 or BigQuery's $12,200. That translates to, what, 75–80% cost savings? So you're getting better performance, total architectural freedom, unified batch, and streaming for a fraction of the cost. It's pretty compelling.
Okay, compelling is right. Now, beyond just the open source side, ClickHouse Cloud, the managed service, has really focused on integrating with Microsoft Azure. That seems like a huge strategic move. What are some of the standout ways ClickHouse is leveraging Azure for its users?
Yeah, the Azure integration is key. And what's really compelling is just the breadth and depth of it. It simplifies the whole data lifecycle, really, from getting data in easily to powering sophisticated AI apps, all within that secure Azure environment you might already have. For example, for agent-facing analytics, ClickHouse Cloud integrates seamlessly with Azure OpenAI. This lets your AI applications basically consume and interpret data in ClickHouse in real time, guiding LLMs like GPT 4.1 to query, interpret, summarize your data, and crucially, keeping all that data securely within your Azure tenant. ensuring compliance, optimizing performance for those AI assistants.
That does sound like a game changer, building sophisticated AI right on your live data. What about plugging into existing Azure data lake infrastructure and simplifying that, let's be honest, often painful process of data onboarding?
Absolutely. They've focused heavily there. ClickHouse offers really deep Azure Data Lake support. Beyond its own native format, it can read and write over 70 different data formats, including popular open ones like Iceberg and, of course, Delta Lake. Since release 25.4, you can directly query Delta Lake tables sitting on Azure, whether they're managed by Databricks or just self-managed by you. And, very importantly, Databricks Unity Catalog integration. That's coming soon to the Azure Managed Service. That will massively simplify using ClickHouse and Databricks together, a really cohesive platform. For onboarding, their engine ClickPipes now has direct connectors for Azure Blob Storage, seamless ingestion, one-time or continuous, with exactly once guarantees for reliability. They also have native table functions for blob storage, Azure Queue for continuous imports, and the Postgres CDC connector. That allows seamless, low-latency replication from Postgres, including Azure Flexible Server, straight into ClickHouse Cloud. They claim 10x faster initial loads, latencies down to seconds. It's enabling what companies like GitLab and Cloudflare call their default data stack. Plus, you can stream from Azure Event Hubs with sub-second latency, and Azure Data Factory natively supports ClickHouse reads and writes. So lots of options.
Okay, it really sounds like they've worked hard to make the whole data flow within Azure incredibly efficient, smooth. What about the developer experience? And integrating with BI tools like Power BI within Azure.
Covered too, yeah. For developers, the ClickHouse Spark connector is available for Azure Synapse. Lets you spin up on-demand clusters for transformations, ML work. And then there's THDB, which is ClickHouse's in-process engine. It now has .NET bindings. This lets you embed those super fast ClickHouse queries directly into your .NET apps, running on local files or object storage. Supports over 60 formats. And there are bindings for Java, Go, Node.js, Rust, Ruby 2, all within the Azure ecosystem. On the BI side, the ClickHouse Power BI connector is now an official data source for Microsoft Power BI. So you can build and publish dashboards using Power BI Desktop easily. And they're working on streamlining the Power BI service experience too.
That really is a comprehensive story within Azure. It sounds very well thought out. Now, for enterprise users, things like cloud architecture, resilience, security, those are absolutely critical. How does ClickHouse Cloud address those on Azure?
Right, non-negotiables for enterprise. They made enhancements like compute separation. This lets multiple compute replicas scale independently, which is great for handling spiky workloads. And a new make-before-break scaling model ensures minimal query disruption when you need to scale vertically, like resizing your servers. These changes significantly boost its ability to support real-time analytics at true enterprise scale on Azure. Security-wise, ClickHouse Cloud is built with all the expected enterprise-grade features: strong passwords, MFA, SSO, configurable IP filters, role-based access control, secure APIs, all data encrypted at rest and in transit, obviously. They also support Azure Private Link for direct, secure connectivity and Microsoft account login. And a really significant kicker for Azure customers: ClickHouse Cloud on the Azure Marketplace is eligible for the Microsoft Azure Consumption Commitment Program, MACC. That means 100% of your ClickHouse Cloud costs can potentially be covered by your existing Azure spend commitment. It can be huge.
Okay, the MSCC eligibility is a big deal for companies already deep in Azure. So stepping back a bit, who is actually using these modern stack components? What kinds of real-world problems are they solving? It sounds like, yes, the lines are blurring, but maybe their core strengths and cost models still point to different best fits.
That's absolutely right. You need to consider the use case. To put it into context, ClickHouse is just a fantastic fit for teams building data-intensive applications, things that really demand that real time, at the speed of Click Insight. Think analytics platforms you offer to customers, or really responsive data-backed CRMs. You see companies like GitHub, YouTube, Twitter, Slack, PostHog using ClickHouse for their really demanding analytical workloads, high scale, high speed. Snowflake, on the other hand, is often chosen by, very large enterprise organizations, AT&T, Capital One, especially if they need deep integrations with a super long list of existing tools, or maybe they're dealing with a lot of schemaless JSON data and aren't necessarily prioritizing open source.
Right, so that raises the crucial question: how should organizations strategically decide? What are the key factors beyond just raw speed and baseline cost?
It often comes down to control and predictability versus bundled convenience, maybe. The modernized by-the-box approach, which you kind of get with open source solutions like ClickHouse, offers really cost-effective computing and very flexible scaling because you explicitly separate storage and compute. You have more levers to pull. In contrast, the traditional models, like Snowflake's virtual data warehouse or BigQuery's serverless queries, can sometimes lead to less predictable costs, often higher costs, particularly for compute, or if you do a lot of really extensive data scans, because it's more of a bundled service pricing.
Mhm.
And strategically, the open source nature of both Delta Lake and ClickHouse offers transparency and complete architectural freedom. That helps organizations avoid vendor lock-in, which is a huge strategic benefit in today's rapidly evolving data landscape. It gives you the power to adapt to innovate on your own terms.
What a fascinating deep dive this has been. We've really journeyed from the challenges of traditional data warehousing all the way to the incredible potential of this modern stack built around Delta Lake and ClickHouse. We saw how Delta Lake gives you that rock-solid transactional foundation,
Oh,
and
good.
ClickHouse delivers just unparalleled speed and cost efficiency for real-time analytics. And it's really clear how there's synergy, especially with those deep Azure integrations, is fundamentally challenging the old guard. It's creating new opportunities for businesses to really optimize their whole data infrastructure.
It absolutely highlights a major shift, I think. A shift towards solutions that really prioritize efficiency, adaptability, and that raw performance, but without the hidden costs or the rigid structures we sometimes saw in older paradigms.
Indeed. And as data volumes just continue to explode and that demand for real-time insights gets more intense everywhere, could this blend of open source reliability and specialized performance truly usher in an era where data strategy prioritizes efficiency and adaptability above all else? Redefining what it even means to be well informed about your own data infrastructure. It's a fascinating question, definitely something to chew on.